Hello and welcome back to Ganesh Institute. So we are now going to start a new series based on complex analysis. And in that, let's first talk about the introduction to complex numbers. So what are complex numbers? See, our maths, in terms of numbers, mathematics is divided into two parts. Let me change the color of the pen. So one is real number and another one is complex. Okay. So in real we have all types of numbers like rational numbers, which are in the form of p by q, and p and q are integers. Q is not equal to 0. Another thing is irrational, when we have non-terminating, non-repeating decimal expansions, right? But what if, when we used to solve such type of equations, x square is equals to -1, we used to say, oh, because square root has negative number in it, so we cannot solve it further. So it is not defined as far as real expansion is concerned, correct? But here in complex mathematics, in complex analysis, we consider that negative root. Okay, so it is called iota. What is it called? Iota. Now if I write z as a plus iota b, z is a function and it is a plus iota b. Here a is real part and whatever is associated with iota, that is b, that is imaginary. Okay, so if you have iota as square root of -1, what would be iota square? If you do squaring both sides, root -1, that is square of root is -1. So square root, if you do the squaring of square root, it will be cancelled, so you'll get -1. If you have to find out iota cube, you can write it as iota square into iota. We have just found out iota square as -1 and this is iota. So this is minus iota, correct? So this is how you can calculate the value of this complex numbers. We denote real numbers with R and complex numbers as C. And sometimes you can find out C written as this. So it is like this. Okay, a Greek letter. If we have to talk about basics of complex, let's dig deeper. So it is written here 1 plus iota has to be converted into polar form. When we write a plus iota b, this is the standard form. Now there is another form as well where we have r cos theta plus iota sin theta. R cos theta, if we compare, is a, which is real part, and sin theta is b. R is with both of them. Okay. Now how we have it in graphical format? Let's say we have origin here. This is x-axis, this is y-axis, okay? I have assumed a point P here. Now it is this distance, OP distance away. Do you know what does vector analysis say? This is x-axis. If it is r, can I write it as r cos theta? Because it is x. And it is y, can I write it as r sin theta as per vector resolution? So in this triangle, this bit is equals to this bit. This will be r sin theta. Yes or no? And this will be theta. Correct? This point has to be x comma 0. Yes? Okay. So if I have to show it in the form of polar coordinates, then P will be x-axis at r cos theta, x component will be r cos theta for P, and y would be r sin theta. Yes or no? So this is how we are presenting a point in polar form. Now coordinate 2 comma minus 3 on a plane. We say we have a coordinate plane and here is x as 2 and y as minus 3. So here it is. But when we have to show a complex number like 1 plus iota on a plane, that plane is called Argand plane. What it is called? Argand plane or Z plane. It is like coordinate plane of real axis, right? Real numbers. Now if someone asks you, you have a plus iota b as standard form, tell us about the conjugate of z. When we say conjugate, that means you have p here, you have to make the image here. So for this point, let's say p dash, what would be y-axis? It would be minus r sine theta, correct? But x would be same. So conjugate is like keep real part as it is and change the sign of imaginary part. If it is plus, then convert it into minus form. For example, if you have 2 minus 3 iota, if I ask you what is the conjugate? This is z only. So z conjugate will be 2 plus 3 iota. Okay. If you have 0, 2 iota minus 0, let's say, or 2 iota minus 2, what will be its conjugate? Minus 2 iota minus 2, because remember real part will be as it is and only the sign of conjugate will be changed. If you have 2, now find out the conjugate of 2. It will be 2 only, correct? Now one more thing to note here is, if I ask you about OP in triangle OPX, let's say, OP is what? Hypotenuse. It will be square root of perpendicular square plus base square. That means it will be r sine theta whole square plus r cos theta whole square. Yes or no? So r sine theta, that whole square means r square sine square theta and r square cos square theta. Can you bring out r square common, and that r square will come out from the square root to make r, and inside you will be having sine square theta plus cos square theta, which is 1 obviously. You know that, right? As per the trigonometric identity. So OP is r. This r is called modulus or absolute value. What is it called? Modulus or absolute value of a complex number. Okay? If we have quadrants, this is first quadrant, this is second quadrant, third, and then fourth. There is a trick after school to college. You know about trigonometric ratios. We have sine, then opposite of sine is cosec. We have cos, opposite of cos is sec. And then tan, and opposite of tan is cot. Correct? Now, if I have to place these trigonometric ratios in these quadrants, what I will say, we are trying to give them some sign conventions. Okay? We have all, E for all, positives here, because this direction is anti-clockwise. Can you see? It goes from here, anti-clockwise, and in anti-clockwise direction everything is positive, whereas if you move opposite to that, that is clockwise, it will be negative sense. Okay? Now here after school, so in second quadrant you have sine and its converse cosec positive, rest all trigonometric ratios will give you negative value. To college, so here tan and cot, its converse will be positive, and here cos and sec, its converse will be positive. Are you getting my point? So this is how you can relate the sign value. Okay, sign conventions. Now why we require them? Because we have to get this theta. If I'm saying that, see, this is the polar form, r cos theta plus iota sine theta, we can find out r. How? Let's say I have 2 plus 3 iota. What is r? R is modulus, which can be brought by squaring real part and then squaring imaginary part. What will we get? 2 square 4, 3 square 9, 9 4 13. So this is the modulus, this distance. Okay? But what about theta? How can we get that? Theta can be brought using, can you see? Can I write perpendicular upon base, that is r sine theta upon r cos theta, as, just bear with me, I'm erasing it. So what have we got here? We have x as r cos theta, y as r sine theta. Okay? If I have to find out theta, that can be considered as tan theta, which we know perpendicular upon base. What is perpendicular? Y. What is base? X. Correct? So perpendicular is y, base is x. So theta, can we say theta, tan will go to right hand side, so it will become tan inverse y by x. Yes or no? So this is how you can find out the theta. And remember, you have to take the absolute value of y by x. Okay? Now this theta is called amplitude or phase. Okay? Remember these terminologies: modulus and absolute value, polar form, phase or amplitude. Okay? Now one more thing I would like to tell you before going ahead with this question which is written here, that if you have to write the polar form in terms of r and theta, in terms of r and theta, then how can you write it? See, I just show you that this is your polar form, correct? R into cos theta plus iota sine theta. And you know, by De Moivre's theorem, this is e raised to power iota theta. This is cis, right? CIS is the short form. And the cis is equals to e raised to power iota angle. So this is also one way of representing an equation having r and theta. Okay? This is polar form, and if it is asked that what is the Cartesian form, it will be simply x plus iota y or a plus iota b. Alright, are you getting my point? Now, let's see how can we calculate this question. Express 1 plus iota in the polar form. So that means it has to be in the form of theta and r, correct? So let's try this out. This is 1 plus iota, which is rz, let us assume. But according to the polar form, z is r cos theta plus iota sine theta. Yes or no? So if I compare both of these equations, on comparing, what would I get? This is real part will be equal to real. R cos theta will be 1. Iota, if you leave this iota, associating this sine theta, and here iota is associated by 1. So r sine theta is 1. Yes or no? Now, what you are supposed to do, squaring these and add, squaring and then adding both sides of third and fourth equation. What you'll get from here? R square cos square theta. From here, r square sine square theta, and you have to add them. On the right hand side, 1 square is 1, 1 square is 1, and add them. If you can take r square common, cos square theta plus sine square theta will become 1. So r is root 2. Usually we write r is equals to plus minus root 2, but because it is modulus here, which will be in this quadrant, so it has to be positive. Is it fine? Now, as far as, because now I can put this r as root 2 here, but what about theta? I have to find out that value, right? I have to find out the value of theta. How would I do that? See, I have r now, okay? So if I do second equation by first, that is, third by fourth. It has to be fourth by third, right? Why? Because I'm supposed to find out tan theta. So r sine theta divided by r cos theta, right? We are doing fourth by third, is equals to 1 by 1, that is 1. R gets cancelled out. Sine theta upon cos theta is tan theta, which is 1. So you know where is tan theta 1? It is at pi by 4, 45 degrees, right? It has to be in radian to get this polar form. Now we have got r, we've got r and theta, both modulus and amplitude. Can't we find out polar form now? Yes, we can. How? Just by putting it in the polar form. R is root 2 cos theta plus iota sine theta. This is how you can get your polar form, okay? Now in basics, one more thing you should understand, which is principal argument. When you have in polar form r cos theta plus r iota sine theta, you can take r common as well. Theta is your amplitude. In our last question, we have simply written down that theta is pi by 4. But do you think that, we have trigonometric ratios which are periodic? They repeat their value. So if I have to find out principal argument, that will be argument of z, simply tan inverse form. Okay? Tan inverse of y by x. That too in modulus. But simply argument is asked, then whatever your argument, principal argument is, you have to add 2 and pi in it, because this is the period where it repeats itself. Okay, so this argument is not unique. N can be any integer. So pi by 4, if I put n as 1 and I add 2 pi, because this is the cycle of 360 degree, 2 pi. This is 0, then pi by 2, then 90, see 0, 90, 90, 90, 180, 180 and 90, 270, then 360. So after 2 pi it will repeat again. So you can add 2 pi, then 4 pi, 6 pi, 8 pi, and it will give you same modulus. 4 pi by 4 2s are 8, so it will be 9 pi by 4. This can be one argument. So this is how you can find out the polar form. You can place your points in eigenplane. You can find out the principal argument, and you can have De Moivre's r and theta form. I'm hoping that you are clear with these concepts. If so, then let's start working on some major topics from complex analysis in our next video. Till then, take care of yourself and don't forget to like, share and subscribe our channel. Bye-bye.